Excited to see Cam at track tonight. All right, here we go. So, suppose that we have a curve. It looks something like that. And suppose you want to revolve that around the y-axis. We'll call this y is equal to f of x. We have a function. We revolve it around the y-axis, and you get something like that. Since we're revolving stuff around the y-axis, what you kind of want to do is you say, well, I'm going to draw a horizontal rectangle because I'm rotating horizontally. Don't draw this. If you draw a horizontal rectangle like so and you rotate it around, what kind of shape do you get? Get a washer. Second hour, I wanted to start calling these things peach rings instead of washers. They like the peach ring candies. So, whatever. Pineapple slice. Okay. So, here's the problem. If you notice, what determines the inside radius? The function. What determines the outside radius? The function. And when you do pi times r squared minus r squared, what's going to happen? Yeah, you're going to get 0. The functions are going to cancel each other out. So in effect, the horizontal rectangles do not work in this scenario. So we have to decide what we're going to do instead. What we're going to do instead is we're going to draw a vertical rectangle. Now this is new to you because, yes, do draw this. When you draw a vertical rectangle, you're like, well, if I rotate it, it's not really going to fill that shape, but it does. And this is where this gets challenging for people. They can't visualize it. They sometimes get frustrated. You're going to have to work through that. We rotate it around, and we get what's called a cylindrical shell. It's going to be empty in the middle. I'll try to describe how another rectangle. So I drew another one. You can see that that one is right on the inside of it. I'll draw one more on the outside. I'll go ways on the outside. That's up to you. Nope. So what I hope that you're seeing is this type of situation where you have these shapes that are stacked inside of each other. Okay? Kind of like you get those, again, those wooden dolls at Christmas or Tupperware containers or something. If I take these and I unravel them, so what I'm going to do is I'm going to take this shell, I'm going to lift the shell out, I'm going to cut it, and I'm going to unravel it. Kind of like a soup can label. Okay? Think of a soup can label that wraps around. You're going to cut it and unravel it, and so you get this kind of a shape, and it's got very small width. Yep, piece of paper. So you can see in this situation that your original rectangle had a width of dx. Well, that's going to be the width of this shape. Now, if I want to find the volume of this, I just have to take, length times height times depth. The depth or the width is dx. What determines the height? The function. So the function is the height. Oh, that worked out well. But what about the length of the label? Think of a cylinder. How do we find? Okay, it's a circle, and you're going to unravel it. Circumference. Circumference is equal to 2 pi times the radius. Now, what variable do you think we have to use for radius? X. So if you look at this point on that rectangle that we located right there, that has a coordinate of x, f of x. Does everybody agree that f of x refers to the height? Well, the x value is going to refer to the radius. All right, so that's going to give us a formula for the volume of cylindrical shells. If we are going to find the volume of one of those shapes, we have the radius, or I'm sorry, circumference, which is 2 pi x, times the height, which is f of x, times the depth, which is dx. So that's one of them. How many do we want? We want an infinite number. Traditionally, we put 2 pi outside for this. We put x times f of x on the inside, dx, and we integrate from a to b. So that's another type of formula that we can use for integration of these solids. Some people think cylindrical shells are bad. A lot of times it's a much better method to use cylindrical shells than to try anything else. Sometimes you have the choice between using pineapple slices or using cylindrical shells. I like using cylindrical shells a lot, and you'll see why here in a little bit. Flip it over. Find the volume of the area bounded by 2x squared minus x to the third and y equals 0 revolved around the y-axis. See if we can get this done before lunch. 2x squared minus x cubed, if I factor out x squared, I get 2 minus x. So the function looks like this. Now, if I want to bound it between that function and y equals 0 is what part of this graph? Y equals 0 is the x-axis. So that means I can really get rid of that part, and I can get rid of that part right there. And that's what I'm left looking at. Where am I revolving it? The y-axis. So bring it over on that side. All right. Now, this is how you do. Somebody asked earlier, they said, so on the test, will you tell us which method we have to use? No. No. You have to determine which method you want to use. So at this point, you're like, well, I'm rotating horizontally, so I'm going to make a horizontal rectangle. But the function is both the inside and the outside, so therefore, that's the wrong choice. Instead, I'm going to draw a vertical rectangle, and as I rotate that around, it gives me this type of a shape. Instead of the washer method. Yeah, there's a lot of times where you can use cylindrical shells. Yep. Yep. So here's what we have. I'm going to take that shape and I'm going to unravel it. Look at the width of my original rectangle. What's the width of my original rectangle? So that's going to be the width of this rectangular shape here, dx. What's the height of the rectangle? Yep, 2x squared minus x cubed. And then the overall length, 2 pi x. So the volume of one of these shapes is going to be 2 pi x times 2x squared minus x cubed dx. That's one of them. How many do we want? So I integrate 2 pi. I'm going to distribute my x through to get 2x cubed minus x to the fourth. Yes, you need to write the dx. The dx tells me that you used horizontal width in this situation. Now, what are my bounds? Yeah, you got to look at that original area. That original area would have been from 0 to 2. That's your indicator for your bounds. Let's go. Antiderivative of 2x cubed. X to the fourth over 2. X to the fifth over 5. 2 and 0. I plug in 2 and I get 8 minus 32 over 5. So 2 pi times 40 over 5 minus 32 over 5. It's going to be 16 pi over 5. Pretty sweet, huh? Well, just look at what you're doing. I mean, it looks super confusing. Like you show the kids in pre-calc right now, they're like, yeah, I have no idea even where to start. Yeah, you are a wizard. All right, next one. We'll get it at least set up. What does this shape look like? Upside down parabola is going to travel through 1 and x, right? Or 1 and 0, right? Upside down parabola, its area is between x minus x squared, which is my function there, and y equals 0, which is the x-axis. What am I going to rotate it around? So this is different because I'm not rotating around the y-axis, and that's going to actually change our radius. So really, really important problem that you watch. So will save you some points on the test if you follow closely. I've got that shape. I notice that horizontal rectangles do not work, so I'll draw a vertical rectangle. Spin that over the other side. I can see I get a cylindrical shell. Unravel it. What is the width of my original rectangle? That original rectangle I drew. It has horizontal width. We'll call it dx, so that means that this has width of dx as well. What is the height of that rectangle, or the height of my shape that I've expanded here? X minus x squared. And then, as I unravel it, we know we have 2 pi times r. And here's where you have to start thinking about it a little bit more clearly. It's not 2 pi x, and I'll show you why. Would everybody agree that the red arrow refers to the radius? What is this line right here? 2. Now, this is somewhere between 0 and 1, correct? So let's say it's a half. What would then be the radius? 1.5. If this was 11 and this was 4, what would the radius be? You took the right minus the left, right? We talked about that when we were doing washers earlier. And when you're revolving around an axis other than the x or y axis, you'd have to do right minus left. So in this case, the right boundary is 2. And the left boundary is your x value. So it's 2 minus whatever x is. let's write this as volume of the entire piece, 2 pi times 2 minus x minus x squared dx. That's one of them. How many do you want? An infinite number, throw an integral sign down. Last but not least, what are my bounds? What's my original area? 0 to 1. Go get some brain food, and we'll check that. All right, here we go. Two pi times the integral. 2 times x, 2x. Negative x times x is negative x squared. Negative 2x squared is a negative 3x squared. And then negative x times negative x squared is going to be a positive x cubed dx. So I just multiplied that out. What is the antiderivative of 2x? What's the antiderivative of 3x squared? X cubed. What's the antiderivative? And then we got x to the fourth over 4. And we're going to evaluate it. 0 to 1. 2 pi times 1 minus 1 is 0. So I got 1/4. 2 pi times 1/4 is pi over 2, or 90 degrees, right? I'm totally joking, you guys. You will not write. It's a math. No, it's a math joke. Wow. We all good? Last one. Okay. This example, the previous example, you were rotating around something other than the y-axis or the x-axis. That made that example important so that you could understand what to do when you have a different rotation. What's unique about this problem is that there are multiple ways to do it. The previous two problems require the use of the cylinder shell method, okay? This one, I have x squared and y equals x. And we're going to rotate that around the x-axis. Whoop, yep, I screwed up. Hold on. There you go. All right. Please make sure that you don't draw this next part. If I wanted to draw a vertical rectangle and rotate it around and create a washer, could I? Yeah, you could. This is an example where you could use a washer. You could also use a cylindrical shell. Your assignment today, you must make the cylindrical shells. On your test, you could choose what you want, but so yes, you will use dy in this problem. So I'm going to get rid of those, and I'm going to take this, which as Maddie sees, I have a thickness of dy. And as I rotate that down, I get the shape down here. So you can see that the original rectangle has a thickness of dy. I'm going to unravel that rectangle. So dy is that dimension. What is this length right here? What is this length right here? Very good. You would have x squared minus x. But because I'm in terms of y, I have to say that this function right here is x is equal to the root of y, and this is x is equal to y. So therefore, this dimension right here, that length, has to be the root of y minus y. Yep. Now, if you're trying to locate one of these points, you want to be able to use that in order to determine, what the length is as it's unraveled, which is 2 pi times your r value. Now, this is just some y value there, and this is y is equal to 0 there. So what's the distance from y to 0? Just y. So this is 2 pi y. So you don't have to do anything crazy there, all right? So that means that the volume of one of these pieces is 2 pi y times the root of y minus y dy. And I want an integral bound from, anybody know what this intersection is up here? 1, 1, so the y value is 1. So 2 pi times the integral y times y to the 1/2. Y to the 3/2, y times y squared, and dy, 0 to 1. 2 pi times, and I do y to the 3/2. Y to the 5/2 over 5/2 are multiplied by 2/5 minus y cubed over 3. Common denominator will be 15. So 2 pi times, if I get 1, I get 2/5 or 6/15 minus 5/15. And I get 2 pi over 15. So the cylindrical shells is a pretty cool option. You have time tomorrow to work through some of these problems. I know that this is challenging stuff, which is why it's an open note test. But because it's an open note test, I'm also going to make it challenging. I'm not going to tell you what to do for every problem. You have to make sure that you can reference your information, figure it out. Okay? Yes. I would say the problems are going to look very similar. To me, what makes it difficult is when you see it and you don't know the method. So every time, so far when you guys are working through the worksheet, you're like, okay, all I have to figure out is it dy or dx. That's really all you've had to think about. Otherwise, you know it's a washer or you know it's a disc. So I'll get you a study guide tomorrow, and that will show you exactly what you need to be doing. Okay, so here's your I try to cut the assignment down, but you guys, I give you assignments not to try to give you a lot of work to do. I try to pick the problems I really feel are essential for you to do so that you do well on the test. And I looked at all these problems. I tried to get rid of one or two of them. It did not happen. And that tells you that I really believe that they are all crucial to your understanding. I want to be clear. I know that you've had a decent amount of homework with some of these worksheets and other things, but again, we covered the notes today. I would like it if you could go home and get, 3 or 4 of these problems done. But tomorrow, the intent is that you would work on these problems tomorrow and feel good about them. We'll probably start doing some checkpoints tomorrow over problems that you would have on the test. Again, when's your test? Next week, Monday and Tuesday. Wednesday and Thursday this week are going to be dedicated to working on your study guide. If you just choose to work on other homework, so be it. But your study guide is lengthy. I would try to make sure your homework is good to go. And then the test is Monday and Tuesday, open note. All right.